Hey everybody, this is Larry. This is the last day of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's poem. Did everyone know? Right? Okay, yeah. Yeah. Hope everyone's doing okay. Today, rest day. I did, like I said, I did Olympic Queens yesterday, so my upper body's very sore. I just haven't done it in a while. Yeah, and I'm excited to finish this poem because today is Thursday here in New York City, which means it's Severance Day, the TV show from on Apple TV. Let me know if anyone else is watching it because it's been, just very crazy in general. But yeah, let's take a look at today's poem 1092, shortest common shortest common supersequence. Okay, given two strings, we turn the shortest string that has both string 1 and string 2 as subsequences. If there are multiple of them, we turn any. Okay. First thing I wanted to do was just look at the constraints, see if anything crazy, because I feel like, honestly, recently on Leetcode, there has been a couple of problems where the premise is super hard. I don't know why my mouse is being weird, but hang on. The premise is super difficult, and then the constraints are like, oh yeah, except for that you only need 2 characters or something like that. And I'm like, okay, that's why I gotta read the constraints. Okay. Yeah, I mean, this is a hard problem. It feels hard, honestly. The first thing I want to say is that I think for me, and I have to kind of remember whether I'm making this up or not, but I feel like the length of the super sequence, right, is the way naive, we're trying to find the shortest one, but the naive way to think about just getting any of them is to create an upper bound, it's just going to be like string 1 plus string 2 or something like that, right? Or the other way around. It doesn't really matter, right? That'll give you an upper bound. So that means that for each of the character or string length being 1,000, then your max is going to be 2,000 as the answer. Does that give me enough? I don't know, honestly. But then the next thing that I would say is that, well, maybe even one character at a time, is that how do we remove one character at a time? Well, if we just say, for example, from here, on the example 1, right? Hang on. If we just like use one character, then like by looking at the A's, then we know that we can just overlap one, and then the rest we could do whatever. So that's one. And then another, of course, is just the B as well. So I think my intuition is that if we do the LCS, the longest common subsequence, I was trying to think whether I want to make sure that I didn't avoid saying like subarray. That's why I put pause. The longest common subsequence, because if they're similar, then all the extra characters, by definition, you have to put it in somewhere in a way that's not overlapping, and that will give you the answer. Of course, that will only give you the length, right? So, for example, we are able to do the LCS, the longest common. I'm kind of writing it this way to mirror their style, but it hurts me it hurts me as a Python dude to do it that way. But yeah, and here we can just do like index 1, index 2, right? I think today, and if you're watching me for the first time or something like that, then my apologies. But today I am going to skip the dynamic programming explanations, or not the explanation, but the setup rather. I feel like I've done a lot of dynamic programming problems in the past, maybe even this one. So, I don't know. But today it's just, I don't know. I want to focus, because that's not the difficult part of this problem, and I want to focus on that part because I don't know the answer yet, frankly, right? So I don't want to do all first principle things for today, right? But needless to say, even without that part though, honestly, LCS is a very studied problem. There are a lot of Leetcode problems on it. I probably have multiple Leetcode videos on it, so definitely Google that up before you do. And if I'm wrong about LCS, then you learn something anyway if you did. But yeah, so okay. So long as if this is equal to 1 or index 2 is equal to n2, then we return 0, right? And the reason is just because you ran out of characters, then you cannot match anymore. Otherwise, then you have two things, right? So it's either if they're equal, then we go then the choice is going to be longest common. Maybe I shouldn't have typed it out, but index 1 plus index 2 plus the cost of 1 for having one character, right? So maybe you would have best is equal to, we're on the longest, so best is equal to 0 is fine, and then we have best is equal to max best of this, right? Or you just take one of the characters, right? So then you just do this, and it's gonna be this. But oh, what the? I meant, I don't know what happened here. I think I was just like in the middle of talking and then got confused. This happens too much. I gotta stop talking. I mean, for these videos it's fine, but I mean during contests I feel like that's where it's been biting me. But yeah, so pretty, you know, I don't think I created anything that unique for LCS. So hopefully I don't have to explain this much, or at least nothing that is particular to this problem, right? This is just LCS in a thing. And then now we can say, I don't know, what is a variable name? I just say C for common is equal to longest common subsequence from 0, 0, right? And then maybe we could just print out C and or N1 plus N2 minus C, right? Because the common piece is going to be what you remove in a way, but you still need one copy of it, so you just minus 1C, right? Okay. And the reason why I want to do that is this is just to kind of give us Oh wait, this is plus 0. This is my fault. Because I was trying to think about cost in terms of the length of the final thing, but I got confused. So this is not plus 1 because we don't use it. Whoops. But that's why we want to validate these things, right? Is that we want to validate that a step of the way, meaning that, okay, of course I don't know how to do the actual string yet, but my theory, my hypothesis is that this should be the length of that string. So then, well, is it? And yeah, and you can see that I fixed the plus 1 really quickly when I saw that the output was 1, which was obviously not the right answer. 5 should be the right answer for this one, and this is probably 8. I mean, I didn't count exactly, but yeah. So at least you want to be correct on your terms for these problems, right? And then now it becomes the tough part. Actually, I guess that's not so bad then now, right? I mean, of course, we did say that the LCS, but we can just construct the LCS, right? And then that means that every character that's not in the LCS, every character that's not in the LCS, we just add it on somewhere, right? I think that's fine. Yeah. Because if you think about LCS as the characters that we move, we just have to, I mean, and this is easier said than done for now, for me anyway, but the idea here is actually understanding LCS in a way such that you're able to do this, but it's just that the common characters will be in the middle, and then every other characters that you don't dupe up, you just kind of put it in somewhere. Of course, it has to be in the same order in some way. That's kind of part of the tough part, but we can probably figure this out, right? And in fact, I feel like you could probably even put this here as well, right? But yeah, and here then now what we want is actually path reconstruction, which is for these videos I'm always trying to figure out like how much to actually explain and all these things. I think it's probably fun. Let me actually rewrite this a little bit. I know that I was just doing it to be lazy, but we can actually just write like cache as you go to, the reason why I want to write it out, we'll go over in a second, but maybe we have a hash cache, right? And I haven't written this out in a while actually, so maybe this is fine. Yeah, and 2, right? And this is just having a cache thing, and then the actual cache is equal to the value. We can type that out, right? And then now the difference is that we also want a previous, or like a way to reconstruct that path. I guess it's symmetric actually. Because the way that I was thinking about it is that you can do it in either direction of either calculating it from the end or from the beginning. But I suppose this is, yeah, so it's not going to be previous, it's actually next bit, whatever. That's why I was kind of taking a pause, right? And then here, first, you know, for consistency, for kind of refactoring-ish reasons, we want to make sure that the cache that we write is the same thing, right? Or returns the same thing as before. So if it has cache, then we return cache of index 1, index 2, right? And then at the end, we just said, it's the other way around, cache index 1, index 2 is equal to best, and then has cache of index 1, index 2 is equal to true, right? And we just want to run it real quick just to make sure that, you know, nothing really broke. So we still get 5. We still get 8, hopefully. Yep. So yeah. And then now we just want to incorporate this thing to just kind of keep track of where the next best scenario is, right? Yeah. So then here, instead of doing a max function, you could write something like, yeah, if, or maybe just v is equal to this thing. We'll copy and paste. V is equal to this thing if best is greater than, or the other way around, if v, then we set best is equal to, actually I think I want to set this to -1, and the reason is just for better sentinel values, for making sure that one of these things will be true. But yeah, best, we update best is equal to v, but importantly we want to set next of index 1, index 2, and here we can use, there are a number of ways you can do it. The way that I'm going to write is just by using a enum, right? So maybe we can write, so same is equal to some this is a enum thing, right? So I don't know, add index 1 maybe, I don't know, right? Or add string 1 maybe, add s1 is equal to 1, add s2 is equal to 2, right? These are just enums, so don't it doesn't matter that much, but it just allows us to kind of denote these things, right? And then now we do the same thing for the other one, right? So here we have this function, right? So we want to say v is equal to this. If best is less than v, then best is equal to v, and then next of index 1, index 2 is equal to add s1, because basically we're adding this character, right? And then we do the same thing for let me just copy and paste this part to move it. Yeah. And that's really it. Not much has changed. Right? So this one again, you know, it shouldn't break anything because we didn't really change anything to the path. But now going from 0, 0, we have a way to kind of add in all the other characters, right? So basically we want to say, let's say I1, I2 is equal to 0, 0. That's basically our beginning thing. And then while I1 is less than N1 and I2 is less than N2, then we just walk the tree, right? The graph. The way that I like to visualize these is just by thinking about it in a two-dimensional grid kind of way, right? Because basically, yeah, you have, if you want to think of it as a table, then you have index C1 on one side, index C2 on the other axis, and you just kind of walk all the way from one corner to the other corner. So you could even think of it as kind of, in this case, it's not the shortest path because it's the longest thing, weird, but just walking that graph in either case, right? So then now we can do a switch statement kind of. I actually forget how to do switch, so I think it's a case statement actually, right? Case, next I1, I2, something like match maybe. I'm still trying to get good at this because, or just more familiar. I mean, I don't know if you can get good at syntax, but it's just, yeah. So if it's same, then that means that we want to do something like this, right? But we want to also add something to the result, right? So that means that we only add one character, which is the thing where it is the same. So it is going to be string 1 of in. And of course you could take the string 2, but they are the same literally, so it shouldn't matter, right? And then you could just do add 1, and that will be just I1, right? And of course this case we do only add 1, and same thing. You could probably assert that these are all the scenarios, but I think that should be fine. Yeah. And then now you have answer, we could convert it back to the answer, and that's it. And it kind of, you know, without ooh, is that not the syntax? Huh, did I confuse them? I think maybe I did it backwards. That's why I'm trying to get better at it. Right. Same remaining. Is that not the syntax? What was the error again? I run it again. Name capture same X remaining pounds. Did I return or break or something? I don't know. I don't know the. Alright, let me just Google it real quick. I guess, like I said, I really do need to get better at this. Switch statements. I mean, we could also do if statements, right? So it's not necessary, but it doesn't say. Do I need like a default case or something? Yeah. Like a search force or something. I mean, it shouldn't matter. I mean, I guess it could be none, but I don't know what is going on. Is just case 0 is not good or something? I don't know. Like, can we just convert this? It doesn't. No. Let me see. Sorry, friends. Technical difficulty. Larry is learning too. Case is okay. Huh? Oh. So it treats this thing as a... Huh, I didn't know that. I guess I never done it with unums. It treats this as like a capture variable name. How do I fix that then? That's actually awkward. Okay. Well, we'll just... For the purpose of... we'll have to figure out next time. Because I don't want to waste that much time here. But yeah. Well, I'll figure out how to do it with real unums at some point. But hopefully this would, you know, won't change the code that much. Yeah. So there you go. Okay. Oh, I didn't know this case. I didn't know this. I was like, why is this wrong? But the reason why this is wrong is because we just don't finish consuming the characters. So I was thinking about this earlier, but then I got distracted by stuff, as you know. So yeah, so then we append the rest. And really, that's it. I have to increment though, but otherwise that should be it. I think the hardest part about this problem is to kind of understand LCS. And it does actually turn out to just require a deep understanding of LCS. It's definitely obviously not plug and play. You do have to figure out how to do the path reconstruction. And not even just doing the path reconstruction, but understand how the path reconstruction goes into the thing. Yeah, I mean, it is what it is. But yeah, that is all. I mean, okay. So what's the complexity here, right? So the complexity is going to be n1 times n2 because that's the number of states, and each state we do all of 3 operation or 1 operation, right? Because we cache and everything, so it's just a lookup for all these. And then this is just n1 plus n2 because this gets iterated at most n1 times, this gets iterated at most n2 times, and yeah. That's pretty much it. I think I don't know that I explained this problem that well because, like I said, a lot of this requires LCS, and I don't know that how deeply to go into LCS. And kind of there is a little bit of a jump into this, but I think in terms of just me kind of giving some insight versus like literally walking you every step, is that is that, you know, writing this code out actually, like, I didn't know how to do it when I was writing this code out. But I was just kind of realizing that, okay, looking at this construction, what does this really mean to me, right? What this means to me is that when you have two characters and they're the same, the +1 means to me that I'm just taking one of the character, right? Like if you have two A's, you only take one of the A, right? And that's it. And then here, it just means take, in terms of the cost, it means that, well, for the common part, it means take 0, but I was thinking about, like, it takes neither of the strings, right? Neither of the indexes, neither of the characters. But then what I was thinking as I was looking and writing this is that I was like, well, what does this mean in the world where we convert this problem? And the world is that, okay, well, if for both of these indexes, we don't want to take either of them as a dupe, or either we can't or we don't want to, then that means that both of the, well, that means that depends on which path is actually better, whether we skip index 1 or skip index 2 as a candidate. That means that when we skip that character, it has to be in the final result. So that's really basically the idea behind this one. I think this is kind of tricky because I don't even know that I mean, I'm not 100% sure that like I'm not 100% sure how to explain it, because I just kind of saw it. Like, I didn't know that I know it, but did I do it before? I guess I did 5 years ago. Yeah. Huh. And I kind of did it. Okay, so I did it with DP with the previous thing. So I did figure it out eventually. But yeah, I mean, it's the same idea, except for this time I did it top down. But yeah. I think I don't know. Let me know in the comments what you think and how you did with this problem. I think for me, the biggest step, which I kind of had intuition for, was figuring out that I need LCS, because the common pieces are the pieces that, like, the longest common subsequence in a greedy kind of way, or rather, in greedy in that if you have an LCS solved, then that means that by definition, and at this point I only knew the length part, right? Like not the reconstruction part, but I knew that length is the longest overlap, and then every other characters means that they're not on the overlap. That means that you have to add them individually. And then after that, I guess it's just piece by piece. But I don't know that I articulated or explained it that well, because I just kind of saw it. I didn't have any like particular like, oh, because of XYZ, this is why I did it. No, I was just like you saw how I did it. I kind of wanted to explore what this meant, and then but when I wrote this code out, I was telling you how I saw it. I was like, okay, well, how does this function relate to the final result if we were kind of I'm thinking about it in terms of the super sequence instead. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy to good mental health. Have a great weekend, everybody. I'll see y'all later and take care. Bye bye.